Hello friends, this is Durga from ITversity. As you guys are aware, this is backup for my live audience. Those who are joining in YouTube, I might not be able to answer all your questions, so bear with us. That being said, let us continue where we stopped. I will just review what we have covered so far after we started on Spark, and then I will take it from there. So the course is Apache Spark using Scala, which we are talking about. And we started with setting up the Spark environment. We have seen architecture. We have reviewed the file systems. We have gone through yarn. And also we have spoken about setting up the datasets. Then we started on building blocks for Spark applications. We have seen details about parameter files and parameters, Spark configuration, Spark context, and reading and writing data using files. And then we started talking about resilient distributed data set. So we stopped there as part of the last session. So we'll continue from there. So RDD stands for resilient distributed data set. As the name suggests, data set is nothing but a collection. So it's a distributed collection. And the way it will distribute is the data will be read into memory before the data is processed. Resilient because if the task which is trying to process the data, if it gets killed, that portion of RDD or that partition of RDD will be reloaded for the other task to process. Hence, it is called as resilient. Now, let us see how to create RDDs using different approaches. One approach we have already seen by using sc.txt where we read contents from a file which is in HDFS or in local file system and create RDD out of it. There is another way of doing, popular way of creating RDD, which is using collection also, we can actually create the RDD. And the API is parallelized. So if you launch Spark Shell here, I will be demonstrating from the lab, but you can validate these things locally also if you set up Spark on your PC. Okay, but I'm using lab so that it will be a bit faster. And on lab we can launch using yarn, but local we cannot launch using yarn. And then I just want to configure a unique port of this session, which is some 5-digit random number. It will launch the Spark in Scala command line interface. Last time when we tried it on GW02, it failed, but now the issue is fixed. You can do the same thing on GW02 as well. Yeah, you guys have access to gw02.itversity.com. I recommend you guys, whoever is attending the session through WebEx, to use gw02.itversity.com. So almost there. So now we can actually use SC, and then if you hit a tab, you can see bunch of APIs. So earlier I have shown you a text file to read data from a text file. When we run in yarn mode, we can only read it from HDFS or network-based file systems such as S3, AWS Blob, Microsoft Azure Blob, etc. You will not be able to read it from locally. Okay, another way of creating RDD, apart from reading from files, is using a API called parallelize. Okay, so using parallelize, you can pass any collection and you can create a RDD out of it. So let's say I create a collection C equal to 0 to 1 million. This is one of the ways, or 1 to 1 million, not 0 to 1 million. Okay, this is one of the ways to to create the collection of elements within a range. This is Scala approach. So now C is a Scala type collection. You can see the data type. It's Scala collection immutable range inclusive. And we can use this C because it is collection. We can say val RDD equal to fc dot parallelize, and we have to pass the collection name here. Okay. Now it has created a RDD, which is nothing but a distributed collection. Each element in that RDD is of type integer. Just give me a moment. Let me confirm that there are no issues with respect to YouTube.
Building a website is kind of like painting a masterpiece. Except
Yeah, it looks good. I just want to make sure everything is visible on YouTube. Okay. Okay. So now we are talking about this thing. So if you see, the actual type of the collection is parallel collection RDD, but it is assigned to its parent class, which is of type RDD, and each element is of type integer, because each element in this collection is just integer from 1 to million. This is a distributed collection which have elements of type integer. Okay. Now you can perform several operations on this RDD. You can see that by typing RDD dot and hit enter, you will see the APIs. Okay, if you are not on mute, let me do that. No, the noise is from my place only. One guy just walked in and he just opened up the bag. That's why there is a noise. Everyone is on mute. If the noise still persists, please let me know, Pramod. I will check. Okay. So I hope now it is better. So you can see RDD dot, and you have a bunch of APIs here. Okay. You can see map, you can see reduce, you can see many other APIs. Okay. And using that, you can do further processing. Anyway, we'll come back to the processing a bit later. For now, we are only focusing on how to create RDD from the collection. Okay. And uh, and this is one of the ways to convert any collection into an RDD. Similarly, if you want to convert an RDD into a collection, at times we might have to do some additional processing towards the end, and for that additional processing, we have to convert RDD into collection, because if you see, RDDs provide only these APIs and few more APIs depending upon type of RDD, but collection have much more broader APIs. So if there is an API which is available only on collection, which is not available on RDD, and your final output is a smaller data set, and if you want to perform certain operations on that final output, you might have to convert RDD into collection, and that's where there is an API called collect. So this collect will actually convert an RDD into a collection. Now if I say val RC equal to RDD.collect, now RC is of type collection. See here. Earlier RDD is of type RDD of int. Now RC is of type array of int. It is again a Scala collection, whereas the RDD is Spark based collection. You need to understand this difference. Otherwise it can cause a lot of confusion. Okay. Meanwhile, I'll be launching another session. There is some issue with that session because it was open for a very long time. I will close that and open this new one. Just bear with me. Okay, so there is a question here. Priya is asking, will convert the results into an array? It's not, you should not use term results. Instead, you should use term RDD. Okay, so it will actually convert an RDD into a collection. Okay, so the usage of terms is important. Here, result can be anything. Result can be a single number. Result can be a collection. Result can be RDD. In this case, it's specific to RDD. Collect will convert RDD into an array or a Scala type of collection, which is of type array. Okay. So we will see that. We will actually get into those details a bit later. For now, just focus on how to convert an array into RDD. So RDD stands for Resilient Distributed Dataset. Dataset is nothing but a collection. Okay. And as the name suggests, it's a distributed collection. And how it will distribute? It will be distributed in memory. Because it's a distributed collection, it is called as distributed dataset. And the third portion of RDD is resilient. So we are reverse engineering from datasets to distributed to resilient. Why it is resilient? I have explained as part of last class. If you go back to the picture, which we have covered earlier, I think this is the one. Not this one. Let just give me a moment. Okay, if you go to architecture of Spark, so you have executors, yeah, you have worker nodes, which are our node managers. Executors will be created when we launch the Spark shell, and when we actually process the data, tasks will be created. And what this task will get is a partition of the collection, which will be stored in memory. Okay, and that partition is RDD partition. RDD is nothing but collection group of those partitions which is your original data set. So let's say there are 4 tasks to process your data after reading the file. So your data set will be divided into 4 partitions and distributed across all these 4 tasks. Because it will be distributed across all the 4 tasks, it is called as distributed. Okay, why resilient? Let's say this task is died while the processing is happening. A new task will be created by executor, and your Spark context is aware which task is processing which partition of RDD. As it is aware about that information, if the task which is processing the data died, a new task will be created, and Spark context will make sure that new task is processed the same partition which was being processed by earlier task. That means as the collection can be recovered, or the part of the collection can be recovered as and when it is required, it is called as resilient. That's why it is called as resilient distributed dataset. I'm repeating again, dataset is nothing but a collection. Depending upon the number of tasks processing the data, your collection will be divided into those many partitions. As it is being distributed across all these tasks, it is called as distributed. And finally, if the task which is processing a partition of your collection dies, when a new task is created, it will only fetch that partition which was being processed by the earlier task, and it will reprocess that that partition alone without touching the other partitions. Because failover is transparent for you, data is distributed, and it is nothing but a collection. It is called as resilient distributed dataset. Okay, I have covered as part of the last session also. If you still have issues understanding it, we will see it later once we cover all the concepts. how is it able to recover the data set? You don't need to worry too much about it. Spark context will keep track of what each task is processing the data. So Spark context is smart enough to do those things. So when you actually set up Spark, right, there is a code which will be deployed, a compiled code which is deployed on the cluster. That code will be taking care of all these things. So if you get onto any of these hosts, okay, so let me show you. I'm logging into gw01.itversity.com, and from there I will be logging into the other nodes. So if you go on to the any of these nodes where the cluster is set up, there will be a directory structure. Yeah. So you can see here there will be bunch of jar files which will be deployed as part of setting up the cluster. Okay, so these are the jars which are deployed on all the nodes in the cluster. So these things will take care of the failover and all those things. You don't need to worry too much about it. Yarn, Spark, binaries, all these things work together, and it will take care of the failover. Okay. As a developer, you don't need to worry too much about it. You will not be dealing at that level, except those who actually develop the Spark code and Yarn code. Regular developers don't need to worry too much about it. As long as you understand resilient distributed data set means the failover is transparent to you, that is more than enough. Okay, even though you are a developer, you are just a user of Spark and Yarn. You are not actually developing those things, so you don't need to break your head around those things. So Bala is asking another question: does it store the dataset using replication? So replication comes into picture only when file system is involved. So RDD is in memory. As it is in memory, it will not actually uh, use the replication that extensively. Probably it might maintain few copies internally, but there is no configurable component like replication factor the way we have in HDFS. It's a very good question. It's in memory, and actual files will be in HDFS. HDFS will take care of your high availability of your file system. As it has to fetch from disk to in memory, it has to just perform IO once, even if one of the tasks dies, and the same partition RDD partition has to be processed by some other task. So hence there is no exposed concept such as replication factor when it comes to RDD. Okay, but at the HDFS level there is replication factor, so that there is a failover or high availability for your file system. Here we are talking about memory. Memory is transient. If a task goes down while processing the data, it has to reload the data from the file system into memory to process it again. Okay. Now going back to RDD again. So these are the commands which I have ran. First, I have created a collection C from 1 to million, and this is a typical Scala collection. C is a typical Scala collection. Then I have ran sc.parallelize of C and assign it to RDD. RDD is of type RDD, and each element is of type integer. It's a distributed collection. And then when I say rdd.collect, it convert the RDD into an array, and you can perform additional operations if it is required after converting it to an array. Typically, we will convert into an array towards the end if it is required. In very rare cases, using collect. We should not be using collect that often. because if you try to use collect on a 10 GB dataset, it has to occupy 10 GB memory on the driver program from where we have submitted the job. RDD is distributed, whereas a Scala collection is not distributed. So depending upon the size of the RDD, if you try to convert into an array, there will be unintended side effects, such as running out of memory issues, etc. So using collect is you need to be cautious while using collect. You should not do it as and when it is required, as and when you feel it is required. Towards the fag end, while dealing with very small data after processing is completed, leveraging the distributed Spark APIs, if on top of final output, if you have to use any Scala APIs, probably you can use collect to convert into an array. Okay. So that being said, now let me give you a genuine use case when this sc.parallelize work. Okay, it seems it is frozen only for a few minutes. I don't know why. Okay. Okay. There is one reason. For some reason, my wired connection is not working today. So if you see any glitches, please let me know. We will see what we can do from our side. Now I removed the wire and I'm using Wi-Fi. As long as it goes well, we will continue and we will see. So you are again jumping ahead, Gopi. Let's move on. We will talk about it later. Okay. Reduce will not result in a collection. If you actually see reduce output will be only one number. It will not be a collection. The result of reduce will be only one record. Hence, there is no point of collection and all those things. Okay. So now let me tell you a genuine use case where you will be using parallelize. As part of your programs, you don't typically create collections like this and create a distributed collection like this. So no matter how much data you have in HDFS, sometimes you might have to pass some local files and you might want to process as part of your Spark programs. Okay. As I have mentioned to you earlier, if you have to use sc.text file, and if you try to pass local file, a file which is locally existing, if you are running in yarn mode or standalone mode or mesos mode, any cluster mode, it will not let you to read local files directly using sc.text file. If you are running in local mode, it will work. But if you try to run it in cluster mode, it will not work. Let me demonstrate here. So there is a file. Let me see where the. Okay, I will use the this new session which I have created. Okay, not this one. So I'm coming out of this one. Okay, and then for everyone, you can access this data which is here. Okay, and let us pick cards. Okay, and there is a file which is 700 MB and there is a small file which is smalldeck.txt. Let's say I just want to read this file locally, and then as part of future processing, I want to use this file as an RDD for some APIs. Okay, we will see the advantage of it later, but for now, my requirement is to read data from this file and create a collection out of it. Okay, and we have used an API called source earlier. If you remember, as part of dealing with election results, most of you guys have done some exercises. You guys have used this scala.io.source. Okay, I will run the pwd. Okay, so data is the base directory. It's accessible to everyone. Everyone can read data from this. data directory. There is NYSC data, there is retail DB data, cards data, etc., HR data, etc. Okay. So now coming back to this, as you guys have done with election results using scala.io.source to read data from a file within your Scala program. Uh, so Spark-based applications using Scala is nothing but extension to your programming using Scala, right? So what we can do, we can say val cards equal to source dot, I think from file, yeah, from file. I have to give the path. The path is data uh, cards check of cards.txt. Okay, let me see. Let me stop sharing the screen and reshare it. Okay, is it fine now? Are you guys able to see my screen? Okay. Okay, so this is the file which we are trying to read. There is some issue here. There is, okay, let me check the file name, smalldeck.txt. No, import is done. And then I have to give the correct file name, smalldeck.txt, and then dot get lines. What it will do, it will create a collection of each and every line within that file and assign it to cards. Now you see cards is of type iterator and each element is of type string. We can actually say cards dot first, no, cards dot take of one. Okay, I have to use toList before doing this. You can see the data. Okay, so actually here I should use toList also. Now cards is of type collection. Iterator is not collection actually. Yeah, list is a collection. So if you convert into toList, it will be list, which is a collection. Now I can say sc.parallelize val cards rdd equal to sc.parallelize cards. There is a typo here. Okay. Now we have created RDD for our data which is in our local file. Okay. So this is the usage which will be using Parallelize in your applications. On top of using Parallelize for exploring some of the concepts, the main usage of Parallelize is this. If there are few files which you have to process from local file system on top of your data sets which are in distributed file systems, this is the approach you will take. First, you will be using source to read the data from the file, and then you create a collection out of it, and then you create RDD out of it. And then this RDD can be used to join with other RDD and perform additional transformations. Okay. So this is the purpose of using sc.parallelize. Very, very important. We will see it a bit later when we talk about broadcast variable. We will see the advantage of this at that time. Sorry for that. One minute. I will show you. I don't know why it is zooming in. Oh, recording is stopped. No, it's happening. Okay. So let me show you. So you can say cards RDD dot first to get the first record. If you want to print everything, you can say collect. So this is one of the frequent usage of collect. If you want to print elements in RDD, you have to convert into an array, and then you have to use for each to iterate through the collection and print. However, if you are dealing with bigger data set, you should not use collect. It will take forever to print all these records. Rather, you can use cards rdd.first, which will only print the first record. Or you can also say take off 10, which will take first 10 records, and then you can actually print the results from there. Okay, so that is about using sc.parallelize to convert into a RDD. And now we will talk about resilient distributed datasets, which we have already seen. I will give you a more appropriate example, and I will try to show you. So if you are trying to use your local machine, you can run all these commands even on the Spark, which is set up locally on your machine. Or we can also we can also run these commands on the cluster. When it comes to cluster, I don't know why it is zooming in like this. When it comes to clusters, the path will be considered as HDFS path by default. If you run in local mode, the path will be considered as local path. Okay, so this is example for running locally. This is my local path. But if you are running on the cluster, first you need to know where your data is in HDFS, and then you have to use that one. So she is asking, what are the performance implications of loading a file from local FS versus a file from HDFS? So here, from local file system, you should be only processing smaller data sets. If you want to see, your actual data sets has to be in distributed file systems such as HDFS and all those things. Your local file system, it can be network intensive. Okay, as it is network intensive, because if you think about it, if you try to load data from local file system, what will happen? There is only one source from which you have to transfer data into multiple nodes in the cluster. So your network will be there will be contention for your network, which is going out of that host from where data is being copied. You can think through it and you will get the answers. Typically, you should not load your data from local file system. There are certain exceptions where your main data will be in HDFS, which will be processed in distributed mode, and then there will be some small files at sometimes which will be passing dynamically for your program, which might not be in HDFS. Those things you have to use the steps which I have shown as part of this session to convert that into an RDD. Okay, performance will be extremely poor if you try to load it from local file system. You are not using distributed computing effectively if you try to load tons of data from local file system. Okay, so one implication will be network. To answer your question precisely, one performance implication will be on the network. So you are mixing up the things, Sri, here. Lazy evaluation is nothing to do with data. It is about how the program runs. It is not about how the data is being processed. So you should not mix up lazy evaluation with respect to your data. Okay, so so the question itself is not completely appropriate. Okay, even in yarn mode, it does matter. If you have one file server, no matter how powerful it is, and if it has 10 terabyte of data, and if you try to copy, all the 10 terabyte data has to come out from that file server, distributed across multiple nodes in the cluster. So even so that machine and the network out of that machine will be a bottleneck. Instead of running from local file system, if you use HDFS, you have multiple nodes in which data needs to be copied locally. You might not have to even use network in many cases. So we cannot get into all those details as part of this session, but to answer your question, one performance issue can be network. Okay, so you can think about those things and you will get the answers. It is a bit distraction if I start explaining too much about it at this time. We will take this question a bit later. Okay, so let me so she is saying it would take time, take the same to copy the file from local FS to HDFS. So there are two things here. When you use, when you try to copy local file system into HDFS, that you will be doing only once. Okay. If you try to, it's a very good question. Glad that you have asked at this time itself. When it comes to copying to HDFS, you will be doing only once, but data might be processed hundreds of times once the data is loaded. Okay, so even though there will be a bit of contention, and also in HDFS, let's say you have 10 terabyte of data for a period of 1 year. Okay, so on daily basis, how much you will be copying? 10 terabyte divided by 365. You will not be copying 10 terabytes of data every day. So that that contention will not as problematic as we when we try to process the entire 10 terabyte of data loading from local file system into RDD. Okay, even though you will be copying data from local file system into HDFS on daily basis, it's a one-time activity, and you are dealing with only your data set divided by n, where n is number of days. Hence, that issue is not that problematic when it comes to loading data from local file system into HDFS. It's a one-time activity. Whereas once your data is loaded into HDFS, there can be hundreds of times where you have to process the entire 10 terabytes of data. If that is the case, if you try to load the entire 10 terabytes of data from local file system into memory, then definitely there will be a problem. Your server will be server, and the network from that file server will be contention point every time you try to process the data by converting that 10 terabyte data which is in local file system into HDFS. Okay. Good that even though I push back, you ask this question. Okay, now let me take the question from Kishore. Can we load local data for local mode? Yes. So that's what you are seeing here. This is a local mode example. When it comes to HDFS, when you use sc.text file, we have to give the HDFS path. And HDFS path is /public /retaildb /orders. And before using this, make sure you are aware, you confirm that. So compression, we will talk a bit later, Priya. For now, don't bring compression into this. For now, the main intention is converting or creating RDDs from collection or files. So we'll talk about compression whenever we cover it. Okay. So let me finish this. So first, when you one more thing which you need to remember, someone have mentioned lazy evaluation. Now we will talk about lazy evaluation. So if you see this, it will not create RDD immediately. It will be creating RDD only certain APIs are invoked, and those APIs are called as actions. We will see that a bit later. But only when actions are invoked, these will be executed. Until then, these will not be executed. So even if I give the path incorrectly, it will actually pass this command, because it will not evaluate this path until an action is performed. The sample action is first. Now if I say orders.first, you can see it is complaining input path does not exist. Oh my god, Skype issue. So my Skype got disconnected. Let me open up the Skype. Can you send on WhatsApp that the Skype got disconnected and I'm joining back? WhatsApp, web WhatsApp will not work here. Yeah, I think now it is okay. This is actually WebEx issue, not in internet connectivity issues. WebEx is acting a little bit weird today. It will be done at 10. Okay. Okay. So, okay, I will take that. Sorry. That's fine. So I might have to stop for a moment. Means I might have to pause for a moment in 5-10 minutes. Okay. And we will continue. We will not stop, but I need to pause. So let me. Okay, there is issue with WebEx now. My previous session is still active. I don't know what to do now. Okay, now it is fine. Okay, let me share my screen now. Okay, the YouTube session is also got disconnected. I have to set up YouTube. Huh? No. Let us set up YouTube. So let me share my screen. Okay, so I hope you guys can see the screen. So now you can see orders.first is actually failing. Input path does not exist. I hope you guys can see my screen. Please confirm those who are on WebEx. Can you guys see my screen? Those who are on WebEx, yeah. But if I use correct path here, we can see the first record. So the way you should validate is first you need to make sure that this part is correct. Okay. I started sharing my screen again. I think it should be okay now. So this WebEx is okay. Yeah, WebEx is behaving a little bit weird today. Anyway, so if you go back to my other session, I can run Hadoop fs-ls and give the path, and it should have some files. Only then you will be able to read. So sometimes your file system might be different from HDFS, or your Spark might have been integrated with S3 or Azure Blob as part of your environment, and then you might want to read from HDFS. At that time, what you can do is you can also give the path using HDFS URI. Okay, which will be HDFS:// and then nn01.itversity.com is the node on which HDFS is running. And then 8020 is the port number. This is called as name node URI or URL. And then you can run it. So if you want to read it from any other file system, then whatever is integrated by default, you have to give the appropriate URI. In this case, I am demonstrating using HDFS. If it is S3, it has to be S3 and colon / the bucket name and then the hierarchy. But to access S3, you need to set access key and secret key. Only then you will be able to read it from S3. Otherwise, you will not be able to read it from S3. Okay. So depending upon the file system you are reading, you need to take necessary action. So that is about reading files from file system. So the next topic is overview of actions and transformations. Before we start, let me move on to a different room. Just there will be pause for a couple of minutes, and then we will take care. Sorry if there is a background noise. So I will filter out this thing once the video is streamed to YouTube, so that this portion will not be there for future folks. I'm almost there. So can you guys hear me? Yeah. So now let us see. Actions and transformations are the ones which actually process the data, and we will see what are they as part of this. But before going into that, we have to review a bit about directed acyclic graph. And I have already explained a bit earlier, but we will see. A typical Spark-based application might run multiple Spark jobs. So there will be multiple Spark jobs in the life cycle of the application. So once we launch Spark Shell, whenever you see an action, it will run into it will evolve into a job. So let me show you by going to the Spark URI. Sorry, Spark UI, Spark UI. So this is the port number. So I can use this. Go to here and then bw01.ituniversity.com. So you see, one Spark session result into multiple jobs, and each job ends with like first, collect, take, etc. First, collect and take are nothing but actions. Okay. Until then, it will not execute the job. Even if you run a jar file, I will come back to a question. There is a question. I will come back to that. Even if you run the jar file, there can be multiple actions which will be invoked within that jar file, within that single jar file. So whenever there is an action, there will be a job associated with it. Okay. So when I say a typical Spark-based application might run multiple Spark jobs, means whatever I have explained. And then a Spark job is nothing but tasks, and those tasks are grouped as stages. Shakti, I will come back to that question in a moment. So let me finish off these things. A job is nothing but tasks, and tasks are grouped as stages. So if you go to the UI and if you click on any of these jobs, there will be stages. Okay, and each stage will have tasks associated with it. You can see that there are 2 tasks associated with this stage. So a job is nothing but bunch of tasks, and those tasks can be grouped as stages. So stage 1, there will be certain type of tasks. Stage 2, it will have certain other type of tasks, and we will see that what those tasks means, what those stages means a bit later. 1 minute. Okay. And then each task apply transformation or action. So each task which will be running will apply a transformation or action. A job ends with an action. Typically, an action is nothing but previewing the data or saving as file into HDFS or some other file system. We will see that extensively later when we talk about job execution lifecycle. So once we actually develop a word count application here, I will explain the life cycle of the program, execution life cycle of the program, and we will see that in detail at that time. And then lazy evaluation and DAG. To understand the difference between transformations and actions, you need to understand or recollect Scala's lazy evaluation. So in Scala itself, there is a concept called lazy evaluation. For example, now I am writing a bit of Scala code. If I say val a equal to sleep of 1000, I forgot the actual syntax. It's not mine. I forgot the syntax. I think I have the code in this. Yeah, thread.sleep. Okay, so it actually waited for those 1000 seconds, so 1000 milliseconds. I think 1000 milliseconds is 1 second or something. Yeah, 1000 milliseconds is 1 second. If I say 10,000, it will wait for 10 seconds. And then it returned. So it immediately executed, and we got whatever is required as part of A. For example, if I say val a equal to thread.sleep of 10,000, and then let's say 100. So a integer 100 will be returned into A. Finally, A will be sorry. Okay, still it is unit only. Okay, let me do this. Yeah. Now you see. Now let me do this. Val a equal to thread dot sleep 10,000 and then 100. So it will wait for 10 seconds, and then A will be assigned with 100. So A will be of type integer after waiting for 10 seconds, and the wait happened immediately. So the execution of this expression happened immediately. Whereas if you use a keyword called lazy, and then say val, probably my voice might be breaking because I can see that internet is a bit slow. It is taking a bit of time to type. If that is the case, if my voice is breaking, let me know, because this is whatever we are talking about is very important. Today's session and also next 3-4 sessions is very, very important. So now when I say lazy, you see here, it did not execute or evaluate this piece of code immediately. Okay. So that is why we are saying that evaluate it lazily. So when it will be evaluated, whenever we use A for the first time in our program. So if you write a complete program, you might create a lazy variable sometime in the beginning, and then whenever you invoke for the first time, it will actually run. Okay. Now if I say B equal to A, val B equal to A. So I'm using A for the first time. I'm assigning whatever is returned to A to B. So it will wait for 10 seconds now. When I ran this, it did not wait. It come out immediately. But now it is waiting for 10 seconds. And 100 will be assigned to B. After that, whether you run A or B, it will be throwing the results immediately. So lazy evaluation means it will wait for the first usage of that variable, which is defined as lazy. So in Spark, lazy evaluation is implemented by default. All your transformations APIs which you try to use will be lazily evaluated. It will not. It will not actually perform the processing immediately. For example, when I say sc.text file and try to read 10 GB of data, it will return immediately because it is not being evaluated immediately. It is just creating a lazy variable. And then when I execute an action like first or take of 10 or other action, then it will actually load the data. First time when I try to execute, it will load the data. So the benefit of lazy evaluation is instead of executing immediately, it will execute only certain actions when the certain actions are performed. That is the benefit of lazy evaluation. Okay, in this case, we try to read the data using sc.text file, but it will not execute immediately. Instead, it will create something called DAG, directed acyclic graph. And it will create the directed acyclic graph depending upon the usage of the APIs. And when an action is encountered, then it will connect all these dots and execute in a sequence. So that is the advantage of lazy evaluation. Instead of executing immediately after each step, it will go through all the transformations and actions and come up and execute it together using the most appropriate path to perform the execution. Okay. So actions are the ones which will execute the DAG. And those are collect, take, first, which we have already seen. And also reduce, it's an aggregate function, and it will actually, it is nothing but aggregate action. And when you use reduce also, it will actually execute. Can we declare lazy functions or only for variables? It's only for variables. I don't think a function can be lazy, because you will not be executing the function. When you create the function, you just define the functionality. When you will be invoking the function, either while assigning to a variable or when you want to perform certain action. Okay. So DAG is directed acyclic graph, and lineage could be the execution path. I'm not sure. I never heard about lineage in the context of Spark. If you can provide me the link, I will go through it and I will come back to you by tomorrow. I only heard about DAG. And also we have top and take order. We will see these in detail. So there is a separate chapter purely for transformations and actions. We will see these things in detail. For now, I'm just giving all the actions that are available as part of the overview. And before performing the action, after creating the Spark context, in between, we will be using transformations. Transformations are the ones which will define the logic to process the data. It can be row-level transformation, it can be aggregation, it can be join, it can be set operations. For mapping or row-level transformations, we use these things: map, flat map, filter, map partitions. We will see the examples and all those things as we proceed further. These are used for aggregations: reduce by key, aggregate by key, and group by key. For joins, we have join, left outer join, right outer join, co-group, Cartesian. For sorting and ranking, we use sort by key and group by key. For set operations, we have union and intersection. And also we have transformations to control the RDD partitions sizes. Okay, coalesce and repartition. So we will get into the details of each and every of these transformations in next 2-3 classes. So during lazy evaluation, only the compile errors are pointed out and not the execution errors. Like even if a file does not exist during the declaration, it could be okay, but would no, that is not correct. That is not correct. Probably it is a side effect of lazy evaluation, but the purpose of lazy evaluation is not that. Okay, so you will understand when we actually write programs, when multiple APIs are executed as one unit, and then you will start admiring this lazy evaluation, and you will understand more about DAG and all those things. Okay, but whatever you have mentioned is kind of a side effect. Is kind of a side effect because of the lazy evaluation. That is not the purpose of the lazy evaluation. So yeah, coming back to Shakti's question, he has been asking this for a while. When you did take of 10 only, this records moved to HDFS. No, that is not correct. Okay, so I have demonstrated as well. So let me start the Spark shell again. I think she already answered a bit about it. Unless you say save as, you will not be saving into a file. Okay. So I will explain it a bit in detail so that it will be clarified to everyone. So the question from Shakti is, when I use take or collect, will it move the RDD into memory or HDFS? So I have already answered that a bit earlier. So let me explain it again. So I will start with this one. Okay. So here, this path is HDFS path. Okay. And I have created a variable called orders. And I'm trying to read data from this file, which is in HDFS, into orders. So when I say orders dot take of 10 or collect, whatever it is, let's say orders array, what will happen is it will fetch first 10 records from the HDFS file into memory. Okay, so there are two things in memory now. One is your RDD, which is orders, which will be in memory distributed fashion. And then I'm saying take of 10 and assigning it to orders array. So there will be another structure as part of your driver program from where you launch this Spark shell. And it will have 10 records out of our original data set. And it will also be in memory. Okay, so here, this orders array is in the driver program's memory. These orders can be distributed in multiple nodes in the cluster because that's an RDD. Okay, and finally, when I say orders array dot for each println, so now I'm trying to print the results. So between your file system and memory, there is something called standard in, standard out on that machine. Okay, so whatever we are seeing is nothing but standard out. So whatever is in memory as part of orders array, now I am printing onto standard out. So this is just printing on the standard out. It will not be saved anywhere. Only when I say orders array, in this case, orders array is of type collection. So if I say orders array dot hit tab, you will not be seeing any of the APIs to save files back to HDFS. Okay, in Scala also there should be some file system APIs which will facilitate you to save this collection locally. But if I want to save this into HDFS, let's say on orders itself, which is of type RDD, if I say orders dot and hit tab, there is a API called save as text file. Using save as text file, I can give the path /user/dgajraju. This is my home directory. If you want to try this out, you have to give your OS ID. Okay, and then orders demo is the directory name which I want to give. Okay, again it got froze. Okay, let me stop sharing now and start sharing again. Can you see now? WebEx is behaving weird today. Okay, so this is the command I have ran, orders.save as text file. Now, when I say save as text file, it will actually copy the orders data into this location. That we can actually see here. Hadoop fs-ls and hit enter. You can see the files. Yeah, you can unmute and ask.
Can you hear me?
Yeah, I can hear you.
So my question is that, see, an RDD is in-memory, distributed in-memory, right?
Yeah.
So which means it is working on some file system like HDFS or
no. RDD is in-memory collection. Okay, there is nothing file system once. So while creating the RDD, when I say sc.text file, the logic in that API will be doing IO on the HDFS file system and create a in-memory collection. Once RDD is created, it is nothing to do with HDFS anymore, unless it has to be recovered again.
Yeah, but when we do take action on that, it has to store in a distributed fashion.
No, that's what I have explained. So when I say take off 10, the underlying logic will be to read whatever is there in RDD, which is in memory, and create a collection out of it. And collection is nothing but an object. Object is nothing but a memory structure. It will be in memory only. That's what I have explained by showing here. Okay, so here I said orders.takeoff 10, and I told that orders will be distributed on multiple nodes in the cluster, whereas orders array is nothing but a in-memory structure, which will be on the driver program from where you have launched this session. And what is this in-memory structure? It is nothing but array. It's not a file. Here we are not talking about file. We are just talking about a Scala object.
But the orders will be distributed.
Orders will be distributed, and it's a in-memory it's a distributed in-memory collection. Again, there is no file system involved in it. It's just a memory structure. So both orders and orders array are memory structures. Okay. Once you execute this, when you perform the action, right, it will start executing. So when the text file is invoked, the functionality of that is to do IO on the files which are located in this and copy it into the memory in a distributed fashion. RDD is a in-memory distributed collection.
Yeah, but that orders might contain terabytes of data, right? So it requires.
Yeah. It requires, if you try to process terabytes of data at a given point in time, you need to configure your cluster with terabytes of memory. But if you think from a application perspective, processing terabytes of data will happen probably once in a decade. You will not be doing that often. You don't need to plan your cluster for those extreme conditions. You might have to break it up and process it, leveraging the existing cluster itself instead of processing everything in one shot. Okay. So yeah, Bala.
Like when you were doing in the first, you were showing the memory that was loaded when we launched in yarn mode everything.
Yeah.
That time, like the same statement, when you just read it, it actually didn't load anything, right? Only when the action was performed, it loaded into memory.
That's what.
Right?
Yeah. That's what I'm saying. It's because of the lazy evaluation.
Yeah. So basically, for the first statement, it's still in the HDFS only, right? I mean, orders would
Orders,
be there, but it actually do not be created.
It will always be in HDFS. Okay, only when the DAG is being executed, it will start doing the IO, create in-memory collection, and then process the data.
Yeah.
Okay, so let's move on. We are spending a lot of time here. It's very basic stuff. We should not spend this much of time on this. So let's move on. We have to explore the APIs. That is more important. So here there are few statements. Okay, so lineage is nothing but execution plan. That's what Gopi is saying. Anyway, that we will see later. Let me see if there are any questions here. So Amog is asking what difference between command. I did not understand, Amog. What is your question? I think she is responding to someone to deal with compressed files. So I'm ignoring that. Okay, so you should not create. You should not have. You should not define any variables as lazy like this. Okay, I think you don't have the files in this location, so it will fail whenever you try to perform the action. So that's what I have also demonstrated. Yeah. So lazy is automatically there for all your transformations and APIs such as text file in Spark. Only when you perform action, it will be executed. Whether you define it as lazy or not, these are lazy variables only. So let me take the Amog's question. Amog is having a question. Amog, I don't know what you are asking. Okay, so Amog is asking the difference between HDFS, DFS -ls and Hadoop FS -ls. So it's pretty straightforward. You just have to run these two commands, HDFS, DFS. And if you see, the output is same. And also, even though you ran HDFS, DFS, the usage says it's nothing but Hadoop FS. So these two are nothing but synonyms or aliases. Both are same. Okay. Either you can use HDFS, DFS, or Hadoop FS for most of these commands. That being said, let me see if the recording is happening. Yeah, recording is happening. Now let's get on to the main topic, transformations and actions. Okay, transformations and actions are nothing but a bunch of APIs to process the data and save it back to underlying file system. Here is the life cycle of any application. Okay, first we need to identify the file system from which we are trying to process the data. Depending upon the file system, you have to determine your URI. You might have to set some certain properties. For example, if you want to use S3, you have to set access key and secret key before trying to use sc.txt file on S3 file system to read the data. So identifying the file system is very, very important. Once the file system is identified, so when I say file system, it could be HDFS, it could be S3, it could be Azure Blob, it could be local file system, etc. And then we talk about file format. So you need to understand what type of files you are trying to read. And also you need to understand the structure of data, especially if your file format is text, including delimiters if applicable, and use appropriate API to read the data. Data will be typically stored in distributed in-memory collection called RDD once we invoke the APIs to read the files. And the APIs that are available are text file to read text data, sequence file to read from sequence files, object files to read from object files, and also we can actually read data from Hadoop file system. Out of these 5, most important one is text file, and then you also probably have to explore a bit about sequence file. Others you can ignore. Okay. Spark also have other APIs to read data from files which are not covered yet, and these will be covered when we talk about data frames. Data frames will provide a bit more APIs to read JSON, to read Avro, to read Parquet, etc. And we will see those when we actually get into data frames. So this covers file system and reading data from the files. Once the data is read from the files and in-memory distributed collection called RDD is created, then we have to apply one or more transformations on the data. Once the transformations are done, then we have to use the appropriate action to write the data back to underlying file system. And repeat this whatever is applicable to process the data as per the requirement. One can perform these actions and transformations on local Spark setup or virtual machines or cloud-based labs provided by us. So you can actually take care of these things in wherever Spark is set up. So we have actions and we have list of transformations which we'll be digging in as part of this lesson. So Spark actions. So there we can actually categorize the Spark actions into converting to array and preview data. So we can use collect, take, first, take sample. We have already seen first. To see the first record, we use first. To convert into an array, we use collect. To get subset of the RDD and convert that into array, we use take. And take sample, it will randomly take a sample number of records if you use take sample. Okay. And then for aggregation, there is a reduce or count. So when it comes to actions, we are almost there. If you read data from file and if you want to do the aggregation, one of the basic aggregation which is also action is count. Okay, count is an API which will execute the DAG and it will get you the count. There are 68,883 records. So to answer the question of Gopi earlier, the actions which aggregate the data will only return one record. It will not return the collection. Okay. As it returns only one record, we don't need to actually use collect or some other APIs on top of this. If you want, you can say a new variable called orders count equal to orders.count. Okay. Similarly, if you read order items, sorry, order items, I'm changing the variable name also. You can say order items dot count 172,198 records. You can say order items dot first to see the first record, and let's say I want to add this value from all the records to get the total revenue. Okay, so from this order items RDD, I have to first transform each and every of these records and extract this so that I can actually compute the total revenue. The way I can do it is I can use order items dot map. Map you have seen as part of the Scala collections. Whenever you pass one record, if you want to get a transformed record as output, you have to use map. As part of map, you can hit tab here to see the syntax. Again, it takes a function as parameter. That function takes one parameter and returns one value. For each input, it actually returns one value, and the final output of the map function will be RDD of this return type. Okay, so here you are passing each record at a time from order item, which is of type string, and I want to extract the order item subtotal, which is this one, which is of type float. So the output will be RDD of float. Okay, so here I can say I will create a new variable here, val order items subtotals. Okay, and then record is of type string, and I can use split. Delimiter is comma, and I have to extract this one. So this is 0, 1, 2, 3, 4. Okay, so I have to get the fifth element by using 4, and it is of type float, so I have to typecast it to float and hit enter. Now you see order item subtotals is of type RDD, and each element will be of type float. So I can say dot first to see the first record. It is nothing but order item subtotal of that record. And now if I want to compute the total revenue after typing the variable name dot and hit tab, there is no sum function. In Scala collections, you will see sum, so you can just say sum and it will work. So here also there is sum, but it does not it did not list here. Okay, I'm not sure whether this sum is Spark based API or non-Spark based API. I will have a look at that. Typically we use reduce for this, and as part of the reduce function, it will take two parameters. We can actually see the syntax here. Again, reduce actually take one parameter which is of type function, and that function accepts a parameter which is a tuple, and then it returns a value of same type. Okay, so here we can give aggregator or total, and then order item subtotal. Those are the names of these two elements which needs to be passed as parameters for the function. And then as part of the logic, I just have to add these two, total plus order item subtotal. Okay, and hit enter. And then it will actually print the result. So we might have to understand a bit of understand the APS to make sure it prints in a appropriate value. There will be APS to get this in readable format, but you can actually get the total of all the order items using this logic. And to answer Gopi's question, reduce function, which is an action, will always return only one value. Most of all the actions which are for aggregations returns only one value, whether it is reduce or count. Okay, and then we have APIs for sorting and ranking, top and take ordered, and we have APIs to save the files in the form of text files and sequence file. Okay, as we are close to 10, I don't want to start these things and stop in the middle. We will continue here, top, take ordered, save as text file, save as sequence file. And by tomorrow, we'll try to wrap up all these transformations and actions. And then day after tomorrow, we will be seeing the execution lifecycle of the word count application. And then we will have, I will give a couple of exercises which you can work on. After probably and the entire Spark is done, I will sit with you guys and review what you have developed, so that you we make sure that you gained enough knowledge to to use these APIs and implement some solutions to simulated problems which are close to real time. So that is the plan. We also will cover data science and Spark SQL once this course Spark is covered. Okay. So that being said, if you have any questions, I'll be glad to take those things. Otherwise, we'll wrap up for today. And sorry for the glitches we have in the middle. I don't know why the internet was not working, and also it was a surprise to me that these guys asked me to move to a different room. So originally the session, the class is supposed to be 20 sessions. We are at 13th session today. We might have to extend for 2 more sessions. 20 to 22 sessions, it will be done. So probably next week it will be done. It will work. I have been doing it quite a bit of time. Have you raised this in discuss.itversity.com? If you have raised, paste the link here. I will have a look at it. So Venkat, I will be covering only Scala and Spark portion for the CCA stuff. Okay, so there are additional topics such as scoop, etc. And and you have to prepare those things also to give CCA. Amog, no, we are not done. For today's session, we are done. But there are still 9 more sessions which needs to be somewhere between 7 to 9 more sessions to cover all these Spark related stuff. Okay, Shakti, you have to raise these issues in discuss.itversity.com. We will try to resolve those issues. If we could not resolve in discuss.itversity.com, I will share the screen tomorrow, and I will paste the link. I will have a look at it. Shakti, if you can paste in. No, all these things will work. You are doing something wrong. So unless you you give the complete details in discuss.itversity.com, it will be tough to troubleshoot these issues. So Shakti, can you give me your ticket number so that I will have a look at it? And you have to raise these issues in discuss, Somalia. If we could not resolve in discuss, then I will have a session and try to resolve these issues. Yeah, you can. Cygwin is not a showstopper. If it is not working with Cygwin, you can use the DOS prompt. That is not a major issue at this time. So you just use DOS prompt, and with DOS prompt it should work. Cygwin, probably it might not be able to resolve certain things. That could be the reason why it is causing some issues. But you can continue with DOS prompt. All SBT console, everything works in DOS prompt. Shakti, I could not find the ticket topic in discuss. Probably might not have categorized it properly. Okay, I got it. Okay, this is from Rajesh. So is this raised? Okay, this is very old ticket. You added to this.
I just responded.
Okay. So can you paste the build.sbt file here? Yeah. Dependencies, yes. Yeah. So here it is. You have Spark core space, I guess.
Without, I tried adding Spark. I removed the Spark.
Yeah, so your Scala version is not correct. Your Scala version has to be, let me show my build.sbt. Okay.
It was 12 line.
Okay, so 2.10.6 is the one which I have used. I don't know whether 2.10.1 is correct or not. So your dependencies, I think you don't understand the dependencies properly. Here you can see you are using Scala version as 2.11.8, and the dependency is spark-core space 2.10. So there is a typo here. It should be underscore 2.10, and also Scala version has to be 2.10.x. If you use like this, you might hit into surprises. In this case, the main issue is the missing underscore.
But for SQL, I have 5.1.36.
Yeah, that's what you somewhere you are missing certain things. You need to resolve those issues. Okay. So first, make sure your Spark stuff is working. Then you can add MySQL stuff and see if it is causing issue. Okay. So you need to paste your build.sbt so that we can actually reproduce that issue and get back to you.
Okay.
Yeah. Okay, so it is completely due to typos and incompatible versions. You need to first fix those things, and most likely the issue will be taken care of automatically. Okay, and please raise as new issues rather than updating the existing ones. So even this guy also have the same issue. He also specified space. I don't know why space came into picture. Is it problem with my code? I'm not sure. I need to have a look at it. Whether you guys are copying from my stuff and because of which the space is coming here. I need to have a look at that as well. But it should be underscore here. Okay.
Yeah. Fine.
Yeah, and also version should match as Priya mentioned. So if you are using Spark code 2.10, you have to use Scala version also 2.10.x.
And on the other day, you got in GW02 an error, right?
Yeah, that is resolved now. That is resolved. You can actually.
I'm getting the same error in my local also.
Okay, local I cannot comment where it is breaking. Okay, but GW02 is working. So when it is again, you raise that issue in discuss.itverse.com, then we will see. Okay, so if I go to gw2.itversity.com and I can run Spark shell here and it works. Okay, so it is working. Earlier it used to stuck here. I don't know whether you are getting the same issue or some other issue. For me, it was getting stuck here. Most likely, when you are running local, if you are running into issue, the issue might be different. Most likely it is not the same issue where your session is stuck here. It could be some other issue. You just log it into the discuss.itverse.com and we will have a look at it. Okay. That being said, thank you guys, and we'll catch up tomorrow. Those who are on YouTube, thank you very much for joining the session, and sorry for the glitches in between. And if you have any questions beyond the class, technical questions, please use discuss.itversity.com. And if you have any challenges with respect to environment for practice, go to labs.itversity.com, sign up for one of the plans that are available, which are very economical, and you can start practicing it. And if you have any issues while practicing, again, you can go and ask those questions in discuss.itversity.com. That being said, if you like the session, please click on the like button. It means a lot to us. And if you want to provide the feedback once the video is streamed, please provide the feedback as part of the comment section. That being said, thank you. Bye.